The next example here, a rectangular playground is bounded on one side by a wall and 3 other sides by 60 meters of fencing. All right, now what we want to do is determine the dimensions of the largest possible playground. Okay, now when you're coming up with the largest possible playground, you're looking for the largest possible area. Okay, so we're going to be dealing with area, and we're going to be dealing with fencing. The fencing's on the outside of your playground. When you're dealing with the outside sides of something, what do we know that as? Perimeter, right? So we're going to be dealing with area, perimeter, which is a side plus side plus side plus side, right? Because it's a rectangle. Now I'm going to make a drawing of this one just so you guys can see it. So it's a rectangular playground, right?
And there we go.
There's my playground. Now what's interesting about this one is it's bounded on one side by a wall. So if there's a wall there already, do you have to put fencing around?
Yeah.
No. So this is your wall there. Okay, so you're only putting fence on 3 sides. So now my perimeter is just side plus side plus side. Okay, you should be taking this down first. It helps. Okay. So what I'm going to do here, and we also know, remember, area of a area of a rectangle is just length times width. Now, like I said before, let's keep our 2 variables for these, x and y. So I'm going to say x equals my width, y, that's terrible. Y equals length. Okay. So far, so good? Cool. Now, so if this is my length here and this is my width, this would be x, this would be y, and that would be x there. So now, if I look at these 2 formulas here, my perimeter and area formula, the perimeter one I can just rewrite as area equals y times x, right? Because it's length times width. Okay. Now my perimeter is p equals side plus side plus side, right? So my 3 sides now are going to be x plus y plus x. Now, do I know how much my perimeter is going to add up to in the end? I have 60 meters of fencing to use. So that means my perimeter is going to be 60. So instead of writing p, I now write 60. Then I'm just going to combine some like terms here. So I'm just going to say 60 equals 2x plus y. All right, so I'm looking now to determine, so I have 2 equations, and I want to determine the largest possible area. So my area needs to be a max. So I want x times y get max. All right, so that's the formula I'm going to use. Now I have to take this guy and plug it into here. All right, because I want to get rid of the y variable. So if I get y by itself here, I subtract the 2x over, so it becomes 60 minus 2x equals y. I can now take that and plug that into this guy here. So I'm going to be stuck with x times 60 minus 2x equals 5x. All right. This was definitely the hardest part. Getting these 2 equations, getting this and getting this guy here. All right. Now this is completely the same as what we were doing yesterday with these guys. Okay? So I'm going to do distribution. I get 60x minus 2x squared. Okay? Now, my A value, just by looking at it, what is it? It's negative. My graph opens downwards, so my vertex is a max. Quick little check, right? Because when you're making up your own equations, you can come up with just about anything. So this is a nice little way to let you know you're on the right track. Okay? So now I find P. Well, I'm running out of room. Sorry, this is kind of a mess, but that's all right. P equals, remember, negative B over 2A. So if I plug that all in, it's going to be negative 60 all over negative 2 times 2. Right, because my A value is negative. So that's 60 over 4. If I work that out, 15. So that's my X value on the vertex. So if I know X, I can plug it back in over here and solve for Y. 2 times 15 is 30. What? Right, Y equals 30. And those are my dimensions. How's that feel? Not bad? All right. We got time. You want to do one more? Sure. This one's a little more of a review one. There's another. So now, theater company currently charges $12 a ticket. At this price, 450 people will attend for every show. For every $2 increase in price, 25 fewer people will show up. What is the maximum revenue? This one's kind of nice because we've done a lot of these in foundations, and you only need to set up one equation. Okay? So we want to find max revenue. So that's going to be people times number of people who buy a ticket times your cost. Right? So we want to find that sweet spot where we can charge them the most, bleed them dry, but still get the most amount of people in, right? That's where we make the most money. All right, so we know for people, you start off with 450, right? And then we know for every increase, you're going to have 25 fewer people, right? $2 increase. So I'm going to lose 25 people for every increase. And then I also know my cost starts off at $12. And I know when I increase it by $2, right? So for one $2 increase, I lose 25 people. For a $4 increase, I'm going to lose 50 people. So somewhere in there, I'm going to gain or lose money. So far, so good? Now, what we did in foundations is we took this, we found the x-intercepts, and then we found the midpoint between the x-intercepts because that would be my vertex, right? Now what we're going to do is we're just going to distribute this out and solve for p. Okay? Or if you want, you can still find the intercepts and then find the midpoint. Either one's fine by me. It's probably easier actually to find the intercepts and split it, find the difference, but for consistency's sake, we'll do the same thing here. So I'm going to do distribution. Like that, good old FOIL. So 450 times 12. When I combine like terms, it works out like that. So far, so good? All right, now we'll just find P. Okay. What's up?
Give me a big number.
Well, just watch. So it's going to be negative 600. Oh, getting ahead of myself here. Negative 600 all over 2 times negative 50. So negative 600 divided by negative 100, positive 6.
Oh.
Simplifies down pretty nice. All right. So that means my x value is going to be 6. So I want to do 6 increases at $2 a pop. So now if I want to find what is the maximum revenue, so I have to plug 6 into here and solve for it. All right. So I'll do that real quick here. So it's going to be 450 minus 25 times 6 times 12 plus 2 times 6. So 25 times 6 is 150. So 300 times 24. Now that I have to use. 7,200 big dollar bill.
Why is it negative?
It's positive. That's an equal sign. What?
Why is the number so big?
Well, that's your maximum, right? That's the biggest you can make it. That's what you're trying to find is the biggest number, right?
Why do you want it so big?
Because you're trying to make money. Money's what makes people happy, right? It feels that void in your soul now. Right?
For a movie ticket, though.
Theater tickets, man. Is it a theater or movie? Yeah, theater. They can charge more. People pay more for the arts.
That's stupid. That's crazy stupid.
What?
But no.
$7,200? But then think about it, you gotta like pay for your lighting and you gotta pay your actors and all that jazz too, right? You gotta make money. I love it in the